Hello students, welcome to online teaching from St. Charles College, Onitsha. The subject is basic science and the topic is magnetism. Before we continue, we have to look at the specific objective. By the end of the lesson, students will be able to 1. Define magnetism. 2. State 2 laws of a magnet. 3. State the magnetic poles. 4. Using diagram to illustrate magnetic field. 5. List 2 methods of making magnets. 6. State 2 ways of caring for a magnet. Meaning of magnetism. Magnetism is the study of a magnet, its behaviors and its properties. A magnet is a solid metallic substance which has the property to attract or even be attracted to by other weak metallic substances. Loadstone is the metallic iron oxide and it is a natural magnet. A magnet can attract some metals which are called metallic substances such as iron, steel, cobalt, nickel. They are generally known as ferromagnetic substances. That is this group of attractive metals that can be attracted by a magnet. They are collectively known as ferromagnetic substances. Non-magnetic materials. These are metals or materials which have no metallic properties, which has no magnetic properties. That is, they can not be attracted by a magnet. Examples are copper, brass, wood, glass. Collectively, they are known as ferromagnetic properties. Above example show that there is a magnet known as loadstone, a magnetic substance, and non-magnetic substances. Laws of a magnet. 1. Iron filings cling mainly around the ends of a bar magnet. The iron filings is gotten from a grounded iron. Looking at the diagram, you see how this iron, on spreading it on top of a bar magnet placed on top of a white sheet, you will see how the grounded iron is being attracted mainly towards the end of a bar magnet. Observations. Iron filings cling to the magnet. Also, the maximum amount of iron filings clinging at the two ends of a magnet, of a bar magnet. These are the poles of the magnet, the two ends. We call it North Pole and South Poles. Second law. A suspended bar magnet with thread which displays to swing freely in a horizontal plane always come to rest with its axis pointing north-south. Looking at the diagram there, you will see it that instead of being in a level, it will tint, and the bar magnet will be pointing slightly north-south. Then we move over to the third law, which states that like poles or similar poles of a magnet repel and the unlike poles attract. You see it in the diagram in north-south, one bar magnet, north-south, another. You find out that the north, the two ends of the north are the same thing, so they will not attract. But in the other diagram, where we have north-south and the north-south, south pole and north pole are different. They are facing each other, and as such, they will attract. Then, if you are looking at it experimentally, you have to bring two bar magnets together, place take the two bar magnets, try to place them close to each other in such a way that both like poles come to closer. Now bring north pole of one magnet close to the south pole of the another. You will observe that if the two poles you are trying to bring to closer are the same, that is, if both of the north poles are on one side and the south pole are far away, it will repel, it will not attract. But if the opposite poles are together, the force of attraction will be great and they will attract to each other. Here we have magnetic pole and magnetic field. Magnetic pole and magnetic field. Under magnetic pole, and we have south pole and the north pole. That is the two ends of a bar magnet, where we have north pole and south pole. They are the two poles of a bar magnet. A bar magnet shows the representation of north pole and south pole. That is magnetic pole. While we have magnetic field. Looking at the diagram there, you will see what we mean. If you keep an iron filing bar magnet and you spread iron filings on it, as we have done in law 1, that is law of magnet number 1, that says magnetic field. Where we have like poles close together and unlike poles are far away from each other. Then the magnet you are spreading, the filing magnet you are spreading on the bar magnet will be clinging towards the end of the bar magnet, making something like the shape you are seeing. You see the arrow in a bar magnet in the other diagram, showing the areas where the influence of a magnet is being felt. Those areas where the influence of that bar magnet is being felt is what we call magnetic field. Then this magnetic field, we have the iron filings makes a line on that bar magnet. Those lines are what we call lines of force. Lines of force, magnetic lines of force. Making of a magnet. How do we make a magnet? We make a magnet that is a fission magnet in 3 methods, using 3 methods. We have electrical method. You see the diagram with a nail, connecting it with in a circuit. When you close the circuit, that nail will be converted into a magnet. Then the second one is by single touch method, where we place a bar magnet on the floor. Then you bring a substance to be turned into a magnet, place it in one end of the bar magnet, and roll it over the bar magnet until the end of the south pole, and remove it. When you remove it, that object has turned into a magnet. But this type of magnet that is made in this form is a temporal magnet. Then we have the next one, what we call the double touch method, making of a magnet through double touch. In this double touch, it is the same method we use in single touch, but in this time around, instead of making it the pressing once, we do it another time, making it double, pressing it on the bar magnet until you reach the end of the bar magnet, then you remove it. Then the object has turned into a magnet. This is more of a permanent magnet made using double touch. Care of a magnet. Care of a magnet. We use different methods to care for a magnet. 1, you store your magnet with a keeper. This is the diagram. If you look well, you see a bar magnet on the floor. Then this U that is inverted in the keeper is what we call the keeper. That object is the keeper. You use it to store your magnet so that it does not demagnetize or loses its magnetism. 2. Store your magnet in pairs. 3. Keep your magnet in a dry place. 4. Keep your magnet in a non-ferromagnetic space. 4. Magnet cannot be heated. You don't heat a magnet with fire or with any type of heat. You don't heat it. 5. Try and keep your magnet separate from strong electrical current. That is from electrical current or any circuit at all. You don't keep a magnet there and on your circuit. It will destroy the magnetism inside the magnet. Then the final one, the magnet should not be hammered at the end when pointing in an east-west direction. If the magnet is placed on the floor, it means it is pointing in an east-west direction, and you should not hammer a magnet in that form when it is in the east-west direction. But you can hammer it when it is pointing north-south. There will be no problem. But you don't hammer it when it is pointing southeast-west. We have come towards the end of our lesson, and we have our evaluation, which will form your assignment. 1. What is the magnetism? 2. State 2 laws of a magnet. 3. What is the magnetic pole? 4. With a diagram, illustrate magnetic field. 5. State 2 types of a magnet. 6. Mention 2 methods of making a magnet. 7. Mention 2 ways of caring for a magnet. Then you reach me through the contact, WhatsApp contact 080-686-32319. Onyeka Benedict is my name. Thank you.